Hello and welcome again to the J-Axis on YouTube. This is your host, Jason Lewis, today to talk to you a little bit about my philosophies on time travel. And it's one of those subjects that, it's still kind of hard to speculate on. There's many different ideas, so I thought I would share mine. And to start off with talking about time travel, we got to think about what time is, how we measure it, how it's governed. And from what we can observe, time is governed by the forces of light and gravity. And we see that with light, especially with cycles, day and night cycles that occur based on light that's shined upon a celestial body. And obviously within gravity, because of different orbits and rotations that celestial bodies take to measure different aspects of time, whether it be in its hours, days, weeks, months, all really based on celestial bodies and the gravitational forces between them, as well as the light and how much light they receive as they're spinning around. And one of the reasons that we can see this is definitely playing into time through eclipses, because when an eclipse happens, you see a perfect overlap, like when we have a lunar or solar eclipse that we can witness on Earth. And when you really think about that, they're predictable, these eclipses, just as like lunar cycles and yearly cycles are predictable. But the way that the celestial bodies overlap, despite their size and their distance, and it's a perfect overlap, it shows you that the gravitational balance between these celestial bodies literally perfect. And when you really think about that, all the different ways that the moon could be rotating around the Earth, and just so happens to align perfectly, with our perspective of the sun to block a few seconds. That's really unbelievable when you think about it for a second. And it shows you how the gravitational balance is perfect and how gravity definitely is a governor of time. And when you start thinking about time and what it is, you have to think about space, because space and time connected. It takes X amount of time to travel Y amount of space. We see this in the fabric of space-time, and the fabric of space-time is literally outer space, and that's anti-gravity. So we're seeing these forces of gravity within celestial bodies, which are acting like just giant hands of a clock in different levels. Everything rotates, whether it's moons, planets, stars, galaxies, all just different hands on a multiversal clock in different celestial levels. And the fact that all these gravitational time measurements are literally existing upon a plane which is anti-gravity, and that's the plane that we call outer space-time, showing you how these two forces really are both necessary to nail down what time is and how it can be affected. You have to be able to affect both forces in one way or another. And when I start talking about wormholes and, the type of wormhole that you would need to be able to time travel, there's different kinds if you really think about how we're going to be able to do things like this in the future. Because if you want to time travel, you're traveling to the same universal space in different times. It's different than if you were to interdimensional travel to somewhere else in the multiverse, where you could literally jump from one space to another through the overlapping time that they share. Time travel would be jumping from one time to another based on the universal space that they do. And that shows you that when we start to really figure these things out, there's going to be different types of wormholes. We're going to have to learn how to bend space and time in different ways to be able to access different higher dimensions and different parallel realities, which, compared to our own. And when we start thinking about making giant leaps like this, whether it be in space or time, one analogy that, I love to use, it's one that I heard when I was growing up, is they always talk about the piece of paper. And the piece of paper is just a, two-dimensional plane, but we're going to compare it to 3D space or outer space example. And on each end of the paper is a dot. And we're going to say that each first dot represents the time we are in, second dot represents the time we want to go to. Now, the shortest distance between those times, if you're looking at it on that plane, would be a line. But if you're able to literally, manipulate that plane the way that you want to, you can find the perfect symmetry point in those 2 points, folding the space and making them overlap. And that is really how I believe that time travel and interdimensional travel and things like that will be achieved. That it's not going to be us necessarily taking a large leap through space or time, but more or less folding the space or time so that wherever we're trying to go overlaps with our current and original space and time. So when that happens, and you imagine like the paper and it folds over and now they're overlapped, that's really the shortest distance between them. It's the path of least resistance. The shortest distance between them is 0. They coexist somewhere in the multiverse if you know how to use gravity and light to manipulate the fabric of space-time. So as that happens, and the fold happens again, and you've reached where you want to, when the unfold comes out, it's almost like if you were to fold the paper over one way, it would fold back the other way. And now you're in your destination of where you're trying to go. And the way that I think that we'll really be able to accomplish something like that is by using illusions to convince the forces like light and gravity, which govern time, as we discussed, that those 2 different points in either space or time are coexisting. You can see this in illusions of geometry when you're looking at specific shapes. If they're set up a specific way, they can cause a perspective of 2 different points or even the same point being able to be either in the foreground or the background. Now, both those perspectives are true. They both exist. So if you could use a similar, illusion between 2 different spaces or 2 different times and use light and gravity to create some sort of illusion, whether, it's things like reflection or reverse rotoreflection, like you see when you look into a fan and it's spinning really fast, and it's spinning so fast that it almost looks like it's actually moving slowly in the other direction. So there's all sorts of different illusions that we can use to kind of manipulate light and gravity in different ways. And I believe when we discover how to do it right, we'll literally be able to create an illusion that convinces light and gravity that the illusion is real, the same way that when we look at a certain picture where something can be in the foreground and the background, both perspectives are real. We've convinced our perception of that, at least. So if we can convince the perception of light and gravity that space and time are being bent, they very well might just bend on their own. I think that's going to wrap it up for time travel. Time travel isn't something that's intangible or impossible. It's within our reach. And it's really once we discover how to harness these natural energies that we know govern things like such higher dimensions, such as time and space, that we'll really be able to manipulate and affect them to our will. As always, I appreciate you tuning in and entertaining my theories. The next episode, I'm going to talk a little bit about some math. I'm going to talk about numerical symmetries, because at the end of the day, that all plays into this, you know what I mean? It's the math that sort of backs up what my science theories have become. So I definitely want to get into that next time. As always, I appreciate you tuning in, and I'll see you next time.